Hello and welcome back to the Arduino Python series, and this is the tutorial number 19. Today we are combining several components into one comprehensive project: a tilt sensor, a relay, an RGB LED module, a buzzer, and a DC motor with an L298N driver. So we will build a system that reacts to tilt. How? I'm gonna say when the sensor is tilted, the motor will stop, a red LED lights up, a buzzer sounds, and a relay activates. When it's a level again, the motor runs, a green LED lights up, and everything returns to normal. So this project ties together many of the concepts we have learned so far, like digital inputs, multiple outputs, PWM, and state management. By the end, you will have a versatile safety or alarm system that you can adapt to your own project. Today we have everything we needed for the last session, but we have two more things. You already have them because we had a lesson, about how to drive a DC motor. So you need your L298N motor driver module, and you need your DC motor, a gear motor or any small DC motor. Okay guys, so about the hardware, the relay, the RGB module, my tilt switch, and the buzzer, it will be exactly like the previous lesson. The only thing that we need to add today, okay, so this L298N module and my DC motor. Okay, so this is what we have to add today, right? Okay, in order to add this, you also need your power, external power supply module again. Okay, so I'm gonna just start wiring my hardware. Okay, so these two outputs, they goes to my DC motor. Okay, so these are the outputs that goes to the DC motor. Okay, and the middle pin, these three pins here, the middle pin is the GND or the negative. Okay, so I'm gonna just connect it to the negative of my breadboard. Sorry, this is positive, just be careful, do not make a mistake. So this is the negative, and it was the input, from your external power supply. But today we want to control the motor, with our relay. So the input, the 12 input of our motor module, we're gonna use from the output of our relay. So from output of our relay, we're gonna just connect to the input of our motor module. Okay, so let me just start it. But the middle pin is the common, in your relay. Okay, let me see. Okay, so the middle pin, this one is common, this one is normally open, and this one is normally closed. It depends it depends on the state that you want to use. You can use normally open and normally closed. So normally open means it always open unless the relay just turn on, and normally closed means it's normally it is closed unless the relay will get turned on. Okay, so now I'm going to use my normally open pin. Okay, the normally open, so the output of my relay will go to the input. Okay, this is the 12 volt, right, if you can remember. So it goes to the input of my motor driver. Okay, just be careful to tight everything. Okay, now how I can use my external power supply, the input, the positive part of your external power supply, right? I mean the red one. For me it's the red, but maybe for you it's different. So this one goes to the COM port, or the common port of your relay. Okay, So I'm gonna connect my, the 12 volt of my external power supply to the COM port of my relay. Okay. Okay, so this is the common port of, this is the input from the external power supply. So the only thing that left for now, it's let me put it here, guys. So this is the negative part of our external power module. So how we can do that? The GNDs, as if you can remember, all the GNDs should be common. Okay, so I'm gonna just connect the negative of my external power supply to the negative of my breadboard. Okay, so now there's two wire left. If you can remember, these the two pins. Okay, these two pins, they were in 1 and in 2, and this one is ENA. Okay, just a very important thing, guys. If you can remember, in the previous lessons we removed these plastic jumpers. Okay, so we removed this, but for this lesson you need this jumper. You have to install it back. So be very careful, guys, because we don't need to change the speed of our motor, so we have to install this plastic jumper back. So I'm gonna install it back. Just I emphasize one more time, don't forget to install this. So from the ENA, the ENA, because it controls the speed, although we don't just need to change the speed, but this pin should goes to the PWM pin on your Arduino board. So I'm gonna the pin that is empty now, the PWM pin that's empty now, it's pin number 3. Okay, so I'm gonna just connect it. Okay, so my ENA, okay, let me just connect the other two. Okay, so now let me connect the IN1 and IN2. These two pins, they control the direction of your motor, of backward or forward. So I'm gonna just connect them to, I'm gonna connect the IN1. I have empty pins here, so I'm gonna connect it to pin number 10. Okay, so IN1 goes to pin number 10, and IN2 goes to pin number 11. And for your EN, the EN pin, so the EN pin, it goes to pin number 3 of your breadboard, and this is the EN pin, the pin that you install the plastic jumper wire. Okay, guys, so this is the wiring of our hardware for today's project. I know this is lots of wire here, but our lesson just become more advanced, so that's why we have so many wires here. Okay, so now we can go and continue. Now let's start coding. So as usual, the first step is to create a new file. So I'm gonna create a new file, and I'm gonna call it like motor relay.py. Okay, so the first step in coding, so just let me remind you one more time. Today again, we're gonna, instead of using PyFirmata 2, we're gonna use PyFirmata. So the first step is to import our necessary libraries. I'm gonna say from PyFirmata import Arduino and util and our friendly time library. Okay, now let's set up our board. I'm gonna say board equal to Arduino. So which port my, oh sorry, first of all I have to define my port. I'm gonna say port. You can't just skip this variable, but you know, it's just because we were doing it from the previous lessons, and I am just doing the same thing. So I'm gonna say port, and I'm say COM9, and here I say board Arduino. So which port? I'm gonna use the port number 9. Okay, and this after that we have to create our iterator. So I'm gonna say iterator. I'm gonna use our util library, util.iterator. So where I want to start to use this iterator in my Arduino board. So I'm gonna say, and my Arduino board is, you know, inside the variable. So I'm gonna use the variable. I'm gonna say board. Okay, now let's start our variable. I'm gonna say iterator equal to iterator dot start, open and close parentheses. Okay, now, okay, oh no, sorry, just you just need to start your iterator. So you're gonna say iterator dot start, and a short small delay, a short delay. I'm gonna say time that skip 2. Okay, so why we add this stop? We just we wait 2 seconds to let everything initialize. That's why you know, in the previous lessons we were doing the same thing. Now let's just define our pins. So the first pin that I'm going to define is our tilt sensor. So I'm going to say tilt board that I explained all these things from the previous lessons guide. That's why I am just doing it so quickly, and I explained everything in details. So I'm going to say D2, and if you can remember, I said tilt is the only input that we have in this program. So other things, they are all outputs, like the buzzer, LED, motor, and everything else. Okay, so here we configure pin 2 as a digital input using this get pin. And now I'm going to just define my relay. So I'm going to say relay equal to board dot get pin. So which pin I'm using? I'm using pin number 8. So I'm going to say D pin number 8. And as you can remember, I told you all other things except this tilt, all the other pins, they are output. So I'm going to say O. Now let's just copy this. So we're going to just paste it in the next line. Okay, so I'm going to copy this part. Okay, now I'm going to just define the motor L298N pins. I'm going to say in 1. I just copy and paste it. I say, so I'm going to use pin number 10 for the in 1, and I'm going to say in 2. So this is also output, but the pin number is 11, and this pin, the ENA pin, okay, ENA. So the ENA, it will be pin number 3. Why? Because pin number 3, be careful guys, just change this O to P, because pin number 3 is PWM. So but we actually don't need to just control the speed today, but we just connect this pin, the ENA, to the PWM pin. Okay, now it's time to define our LED, our RGB LED module. But again, one more time, if you don't have the RGB module, you can just use separate LEDs, doesn't matter at all. But don't forget to use resistant. Now I'm gonna say, I'm gonna call for the red, I'm gonna say red, and I'm gonna say, okay, which pin I'm using? I'm gonna use pin number 5. But again, if you can see, these are also output. So I'm gonna say red. Now I'm gonna say green. Okay, which pin I'm using? Pin number 6. Okay, sorry, pin number 6. pin number 6, and the last one is the blue one. So I'm gonna say for that get pin, which pin number? I'm gonna use pin number 7. Okay, now the last thing is my buzzer. So I'm gonna say buzzer. I'm gonna define another variable and say buzzer. So buzzer is also output, but which pin I'm using? Pin number 9. Okay, so now we finished just defining and setting up our pins. Just one more thing, control guys, that if you do not use a pin number just 2 times, because it will show you error. So anyways, 2, 8, 10, 11, 3, 5, 6, 7, 9. So okay, so everything's fine so far. If you can remember from the previous lesson, when we wanted to turn the LEDs, the RGB LED on and off, we used to do it, manually. For example, I was saying red dot right 0 or 1. Okay, but today we're gonna just create a function, and it will make our job is very, very much easier. The reason that I'm putting it in a function is just to show you that how it is easier if you put your LED in a function. So I'm going to define a function, and I'm going to say def, and I'm going to call it set like RGB. Okay, and how many colors I have? I have one, red, G, and B. So I'm going to give it 3 arguments. Now I'm going to say red dot right. So my red is going to be R, and I'm going to say green dot right, it will be G. So I'm using these variables, guys. I'm using these variables here in my function. And the last one, I'm gonna say blue dot right, and I'm gonna give it B. Okay, so as I told you, this simple function writes the 3 values, 0 or 1, to the RGB LED pins at once, and it making it very easy to set a color. Okay, now the next one, again, we can create another function. We can create another function. One function for the safe state, when your tilt sensor is horizontal or when it's not tilted, and another function we can just say, for example, the alarm state, so when your sensor tilted, and we can control everything inside the function. Okay, we can control the motors, the state of the motor, if we want to turn our motor, if we want to turn a light or turn the buzzer on off, everything we can do it in the function, and it will be much more easier. So now I'm going to create first of all, I'm going to create the safe state function. I'm going to say def safe state. Okay, so I don't need any argument now. Okay, so let me the first one, I want to just turn my relay off. Okay, so let me say relay that, if you can remember, if we wanted to turn our relay on or off, we had to say 1, but if we wanted to put it on, we had to give it 0. So now I'm gonna say in 1 that right. Okay, so in the safe mode, we assume that our motor is spinning, our motor is running. So I'm gonna say in 1 dot right 1, and I'm gonna say in 2 dot right. So I'm gonna turn the backward direction off, because I put the forward direction on. So I have to turn the opposite direction 0, I mean the backward. So I turn it off. And I also want my motor to spin in full speed. I'm gonna say en dot right. Okay, so it means that my motor will spin in a full speed. And I want to turn my buzzer off, buzzer. So I'm gonna say buzzer dot right, and I'm gonna give it 0. And now I can use my function. I'm gonna say set RGB. So now I want my red to be off. Okay, so, and I want my green to be on, and I want my blue to be off as well. Okay, so one more time. So with this relay that write 1, maybe again you're gonna ask why I put 1. So you can see, many relay modules are active low. It means a high signal 1 keeps the relay off. That's why I put 1 here. So here the relay is off in a safe state. That's why I put 1 here. Okay, so now we finished the safe state function. So one more function left. We need to create another function for alarm state. Okay, so I'm gonna say def alarm state. Okay, again I don't need any argument here. Okay, so I said def alarm state. It's just a name, you can just give it whatever name you want. In this line now I want to turn my relay I on. I'm gonna say relay dot right, so I'm gonna give it zeros because I want it to be on. Now I want to turn my motor off, so I'm gonna say in one that right 0, also the backward direction, both of them 0, and the speed pin, I mean the PWM pin, so this one will also be 0. And I want to turn my buzzer on, so I'm gonna say buzzer that right, I will turn my buzzer on. And now I want my red LED be on when we are in the alarm state, so I'm gonna say set RGB. I'm gonna say make the red one on, and green and blue should be off. Okay, so this is it. This is about the functions that we created. The first function for our RGB module, the second for the safe state, and the third function is for our alarm state, for when our sensor is tilted. Okay, so now when we run the program, when you press the run, first of all we want to show a message for the user, for the operator, to tell them that the system is initializing. And also I want to turn the blue LED on for a short period, like for example 2 seconds, 1 second, it depends on you. And then the blue will go off, and it depends if the sensor is tilted or if the sensor is at this state. So the green or the red LED will turn on. So how we can do that? First of all, as I told you, we will start by showing a message. I'm gonna say system initializing. Okay, so system initializing, this is the first message that when the user press the run button. And as I told you, we want to turn our blue LED on for a short for a short period of time. So I will turn the red off, the green off, and the blue on. For how long? Now I'm gonna say time that sleep. It all depends on you, but I'm gonna say just keep it on for 2 seconds, and active the safe state. Okay, safe state. Okay, so I call my function safe state, and at the end again just print another message after this message. So what we can say, for example, we can say system ready. So after the blue LED will turn off, the system ready message will come, will show on your console, so the user know that now the system is ready and it will just start running. So from now on it will be exactly like the last session. First of all, we're gonna say last state, because we need to create our main loop. Okay, we finished to define all our pins and our functions. Now we have to create our main loop. So I'm gonna say last state, and first I will give it none. Okay, so one more time I'm going to tell you, use the last state to remember the previous tilt reading. So this let us print messages only when the state changes, and it will avoid the console, it will avoiding console spam. Okay, right. Now we're gonna just create our main loop. Okay, so I'm gonna start with try block, so we can just catch a keyboard interrupt later. So I'm gonna say try, and inside the try I'm gonna say while true is true. Okay, now I'm gonna say state equal to tilt dot read. Okay, so you know why I used dot read here? If you see here, here I told you the only input that we have in this project is our tilt sensor. Okay, see here we put I. So when we put I, it means that we want to read a data. We want to read something from this module, from this sensor or whatever it is. So we have to use dot read. Okay. So we start an infinite loop. Now I want to say that if the reading is unknown, maybe the iterator hasn't received a value yet. So we wait a tiny bit and then we skip the rest of the loop. This will prevent the errors. So I'm gonna say if state is none, then what's gonna happen? Just time that, wait a little bit. Okay, just a short period of time, 0.05, and I'm gonna say continue. Okay. So but what if our state is not unknown? I mean, what if our state is true or false? If you can remember, in the previous lesson I was using 1 or 0. It's just it doesn't matter. Now I want to show you a new method. I'm gonna say this time I'm going to use true or false. So you can see there is no any difference if you use 0 or 1. So I'm gonna say if state is true, I mean if our state is 1 equal to 1, if you can remember from the previous lesson. So if state is true, so what's gonna happen now? If you can remember here, we created this variable to avoid the console spam. So we're gonna use so we want to show a message to say that the tilt detected. It means that this true, it means that the system detected a tilt. But when we want to show a message on the console, we want to show a message in the console if something change happened to the status of our sensor, or if the previous state of our sensor was something else, but now it's different. So how we can do that? I can say, again, I'm going to use an if statement. If last state now is not equal to true, okay, because here we're using true. So now we're going to use if last state is not equal to now, print a message for us. We can say, for example, print tilt detected, and we're going to say motor stopped. Okay, motor stopped. So this is for the tilt. So we say tilt detected that motor stop, and we're gonna just call our alarm state function. So all things that we defined in our alarm state will gonna happen now. So we're gonna call, how we can call it? I'm gonna just alarm state, open and close parentheses. And one more thing, so now that the last state is not equal to true, so it means that it changed. So we have to update the value. How we can do that? We can say last state equal to true. So we're gonna just make it equal to this value here. Okay. So one more time, I'm gonna just explain a little bit more to you. So here in this part, okay, in this part, we assume that the tilt sensor returns true when it tilted. It might return 1 or true, as I told you. Both work as a boolean. If the current state is true, it means if the sensor is our sensor will tilt, and it is different from the last state. This is what we mean. If it is different from the last state, we're gonna print a message, and we're gonna call our alarm state. Okay. And after that, we're gonna just update our last state. So just notice that the message says, here this message says tilt detected. Yes, motor slap. Yeah, I just thought we made a mistake, but it's correct, guys. So now this true finished. So just one more state remain. So it means this was for the tilt. Just our safe state remains. So I'm gonna use an else statement. I'm gonna say else, and I'm gonna say if last state. Now this time, now here I said if the last state is not equal to true. So now I'm gonna say if it's not equal to false. Okay, so now we want to print a message for the user. For example, say a safe position, and we're gonna say motor running. Okay, so we're gonna say motor running, and at the end of this, okay, at the end we're gonna just add a short delay to prevent the loop from running too fast. Okay, so after the loop is finished, it's gonna just come to this time that sleep 0.1, so it will just prevent, as I told you, the loop from running too fast. So this is from our try block. So the only thing that left is we have to define our except block. I'm gonna say except keyboard interrupt. Okay, now again, for example, in this position I want to turn the LED, the red LED on. So I'm gonna set RGB. So I'm gonna turn off, and the red is on. Okay, now I want to turn everything, so turn the motor, also shut the motor off. I just turn the motor off and turn the buzzer on. So I can say in 1.write 0. We could just create another function, guys. For example, call it def whatever emergency button, and we could just define all these things that we're defining here and just use the function. But I just skip it because I say it may be just confusing you. So let's say write 0, and also a dot write this one also 0, and I'm gonna just turn my buzzer on. So, and I'm gonna just safely close our program and exit the board. And at the end, I want to show a message for the user, to the operator, to tell them that emergency happened, emergency stop. Okay, so we just typed it in capital, so it means that something very bad happened. So this is it, guy. I think the coding is finished. Now it's time to run and test our program and see what's gonna happen. Okay, guys, now let's run the program and see what's gonna happen. So this is my DC motor and this is my tilt sensor, and just pay attention to the LED to RGB module. So I'm gonna just press run button. So waiting. Okay, see the blue LED command. Yes, the motor is running. So see, the sensor is now at the horizontal position or at the safe mode. Let me just tilt it. Okay, so now it's just the motor is off and the buzzer is on. Now let me just take it back to the horizontal position. So it's not working. The buzzer is just the buzzer is running and it's not running. Let's just go back to our codes. Okay. Okay. So when so at the let's just save state. So at the safe state, it's working properly because the motor is running, everything is okay. But at the alarm state, the motor, see here we said the motor should turn off, you know, in one, into an ENA, all of them 0, and the red LED should be on. But so here everything is working and it's okay. Now in our main loop, so we're gonna say if state is true, if last state is not true. Okay, print this message, alarm set, last state is true. So far everything is okay. Now let's go to here. So if last state is not equal to false, so this one is also okay. And then we print the message, safe position and motor running. Okay. And this one is also, oh, okay, we made a big mistake. You know, in here, in the tilt, okay, in the safe mode, so we forgot to just to call our safe state, you know, function that we created here. We just print the message and I left it. So it was just my mistake. Sorry. So I'm gonna say safe state, open and close parentheses, and at the end we have to update our last state. So I'm gonna say last state equal to false. Oh, okay. So I think it was making troubles for us because I forgot to just call our save state function. Now let's just go and run the program one more time and see what's gonna happen. Okay, so I press run button. Okay, I hold my tilt switch, you know, horizontally or in safe mode. Okay, see the blue. Okay, so it's running now. Let's tilt it. Okay, the buzzer is on and the motor stopped. Okay, now it's working. Yeah, so that was the problem. Okay, see? Yes. And let me tilt it and let me, yes, again, yes. It's working properly, so everything works properly. Now let me just press the Control C, okay, and see what's gonna happen. Okay, emergency stopped. Just one more. Okay, no, we wanted, oh no, but in the emergency, we wanted to turn the LED on. Okay, but here we made a mistake again. Now the blue LED turn on. So let's just again go here. Okay, see? Yes, I made a mistake here. So in the except keyboard interrupt, in the except, you know, loop, instead of making this to 1, I'm gonna just, because red is our first argument here, see, the set RGB, red is the first argument, so I have to turn the red on. Now let me just try one more time. Okay, so I'm gonna just hold my tilt switch horizontally or in a safe mode. Okay, there's an error here. Could not open cam 9. Let me just run one more time. Okay, so this is just my board is connected. Just let's try one more time. I think, yes, this time I think it's gonna work. I don't know why that error was. Okay, see, the blue LED is showing. Yes, the motor is running. Okay, I tilt it. Yes, green. Now red. Green, red, green, red. Now let me just press the Control C button. Okay, we press Control C, and now see, it doesn't matter if you just change your sensor because we are in emergency mode, nothing's gonna work, and the LED, the red LED will just turn on for error. Okay guys, this is it. Hope you like it and you enjoy it. If you have any question, please let me know. See you in the next lesson.